Hello and good afternoon, everyone from South Africa. My name is Timeno and I welcome you to Edu-thon. Edu-thon is a great program that inspires young people and helps them with their academics so they can do well. So we are here today and we'll be doing some mathematics with you today. We're just going to be looking into one of the chapters of mathematics, and we want to specifically help those who are in the last grade before the university. In South Africa, we call it grade 12. So grade 12 is the last grade before university entrance. So we're going to be looking into, what they do and how they can answer questions regarding trigonometry. So let's start. Of course, we cannot, just get into it without doing some recap. We need to recap from what they did in the previous year, and of course, maybe the previous 2 years. So just gonna do a quick recap, and then we'll jump right into it. I hope you're ready and you will learn some things. If you have any question, of course, you can send them online, and then we will actually help you. Okay. So as you know, when we deal with trigonometry, we cannot talk about trigonometry without talking or mentioning what we call the trigonometric functions. All right. So suppose we have a right angle triangle. Okay. You know that in a right angle triangle, normally we call this side is the vertical side. Is normally the length. The horizontal side is normally the width, and this is normally our hypotenuse. You remember that? Okay. So if we call this angle here theta, we say this is angle theta here, right? We know that in a right angle triangle, it means that this angle is a 90-degree angle. That means that the vertical side, it meets with the horizontal side. All right. So we have your hypotenuse here, and then we want to define the trigonometric functions. We have about 3 of them, of course, with their inverses. Okay. So you were taught about sine, you were taught about cos, you were taught about tan. This is, of course, sine, cosine. I'm just shortening them, and then this one will be your tangent. Tangent. Okay, that's how we call them. So if you want to define, we use this triangle to define the sine of theta. Sine of theta, what we say is that, remember that last year we were taught about what we call SOHCAHTOA. Let me just write it here quickly. So, okay, let me just put it here first. SOHCAHTOA. Okay, so what is SOHCAHTOA? SOHCAHTOA, the S simply stands for sine. The O stands for opposite. And the H stands for hypotenuse. This hypotenuse here. So when you want to define the sine of theta, sine of any angle, it could be, doesn't have to be theta. It could be beta, it could be K, it could be whatever. We just use it to define. Okay. So if you want to define the sine of theta will be your opposite side, opposite of this angle. You say opposite of what? It's opposite of the angle that you are dealing with. If you are dealing with this one here, suppose this is your alpha. If you want to define the sine of alpha, your opposite side will be this one here. But since we are dealing with the sine of theta, our opposite side is this one here. So let's call this our L, and let's call this our W, for example. Okay, so our sine of theta will be opposite. So it will be equal to opposite over hypotenuse. So what is our opposite here? Is L is equal to L. What is our hypotenuse? Is H. So this is our sine of theta. Okay. Cosine of theta is CA. So CA stands for the C stands for cos, the A stands for adjacent. What is our adjacent side? So cos is equal to the adjacent side all over the hypotenuse. So the adjacent side here is our W, and then we are dealing with theta, the angle theta, remember? So, and then our hypotenuse is what? H. Okay, we come to tangent. T is for tangent, O is for opposite, A is for adjacent. So the tangent of theta is what? Is opposite over adjacent side. And what is our opposite in this case? Our opposite is L, the length, and then our adjacent is W. Okay, so this is how you define them. If you can, you need to memorize this. You need to know this off by heart. All right, it's SOHCAHTOA. Sine is opposite over adjacent, cos is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, and then of course I spoke about the inverses of these three functions or trig ratios, if you wish. So for sine, the opposite of sine is called cosine. Okay, so that means that the cosine, if the sine of theta here is opposite over hypotenuse, the cosine of theta will be the inverse of this. Okay, it will be hypotenuse all over opposite side. Okay, so if we are dealing with cos, for example, the opposite of cos is secant, sec. We normally call it sec, but it's actually secant. Okay, so sec will define it as the inverse of cos, and then it will be hypotenuse over adjacent. Okay, so if you wanted the sec of theta in this case here, sec of theta, it will be equal to sec of theta. Remember, the cos of theta is equal to what? Cos of theta is this over this. So sec of theta will be this over this. It will be h over w. All right. So the last one is tangent. So tan of theta, the opposite of tan of theta is called what? Cotangent. So we normally say cot. Okay, so cot of theta in this case will be adjacent over hypotenuse. So this is what you did in the last year. This is just a recap. All right. You need to know these things by heart. All right. So what I want us to look at today is what we call the reduction formulae and the compound angles. Of course, compound and double angles. Okay. So we're going to be looking at the reduction formulae. So let me just wipe this thing off and then we get right into it. Okay. We get right into it. I hope you got something there. So we will be looking into remember that these things, you need them because in your final exam, you're going to be using them. All right. Don't forget, don't learn to forget. So you need to know them off by heart. If someone wakes you up at night, you should be able to say, what is SOHCAHTOA? SOHCAHTOA. Should be able to define it, okay? So let's get right into the compound angles, the double angles, and of course, starting off with the reduction formulae. So let's just define it quickly. So this one here, reduction formulae, is of course strictly for the last grade before university entrance. Okay, those of you who want to be doctors, who want to be nurses, you need to be excellent in this part or with this part of mathematics. All right, if you want to be a doctor, this you need to know very well. All right, okay. So let's get into it again. Reduction formula. So let's draw our triangle. I will just start here. We have a triangle here. Okay, still slippery. Let me just go down a bit. I'm not sure if you can see that. All right, so we have our triangle here. Okay. Now let me actually, I'm going back. I'm actually going back to what I was doing. Let me just draw this here. Just a minute so this thing can dry off quickly. Okay, so if you have this, is called the Cartesian plane. The Cartesian plane, all right, where this we normally say is the first quadrant, this is the second quadrant, and then this is the third quadrant, and then this is the fourth quadrant. All right, so this is your y and this is your x. All right, so this is your what? Cartesian plane. Okay, so this here, remember, if we've ever heard of or on the first quadrant, right? All the trig ratios are positive there. All right. So we say we write A here for all. Okay. in the second quadrant, only sine is positive, the rest are negative. So only sine, of course, sine with its inverse. Sine and what is the inverse of sine? Is cosine. All right. So this, no, not cosine, cosec, not cosine, cosec. So this and cosec, they are positive. Third quadrant, the tangent and its inverse, they are positive. Fourth quadrant, the cos and its inverse, they are positive. So we normally say, we call it the cast rule. Cast rule. Why do we call it the cast rule? C stands for cos. So cos is positive in the fourth quadrant. A stands for all. So A, all of them are in the first quadrant are positive. This stands for sine. So all of them are positive. Sine is positive in the second quadrant, and then tangent is positive in the third quadrant. Okay. So yeah, now in the first quadrant, we will call it 180 minus. Why are we calling it 180 minus? Because all the angles here, they are actually less than 90 degrees. Okay, they're actually less than, sorry, this one here is actually less than 90 degrees. Yeah, but let's look at the 180 first. So we'll look into this. This will call it the 180 degrees minus. Okay, so the second quadrant is what? 180 degrees minus. Let's write it here so you can see it nicely. 180 degrees minus. 180 degrees minus, that's where the sine is positive. All right. The third quadrant is where tangent is positive. So we will call it the 180 degrees plus. Okay. The fourth quadrant, only cos is positive there. So we will call it the what? The 360 degrees minus. And then this one here, because when you start from here, when you actually start from here, this is your 0 point. You move around, you get into 180, you get into 180 plus, you get into 360 minus. Then when you get, again, remember that means we finished a revolution. So once you do this, it's 360 plus. That means these are angles that are bigger than 360. So this one we'll call it 360 plus. Okay, now here's the thing. When you're dealing with reduction formulae, remember we are discussing reduction formulae. Okay, now what is the importance of this? These two here, 180 minus and 180 plus, right? When you are dealing with your sine and cosine, they don't change. You see, so when you are saying sine of 180 degrees minus theta, this remains sine. What you do is that you say, where is this angle here? Or which quadrant is this? 180 minus is the second quadrant. In the second quadrant, we know that sine is positive. So this will be equal to sine of theta. You get? So sine is not changing. If you get to the fourth quadrant as an example, and you're talking about sine, let's say sine of 360 degrees minus theta. Okay, because we are saying that 360 minus is which quadrant? It is the fourth quadrant. And in the fourth quadrant, we know that sine is negative. So what is going to be your answer? Your answer will be negative sine of theta. Okay, why? Because sine is negative in this quadrant. Which quadrant is this? It is the fourth quadrant. Only cos is positive in this quadrant here. Okay, so that's how you discuss it, right? Suppose we are talking about cos. If you wanted cos of 180 plus 180 degrees plus theta, you say which quadrant is 180 plus? It is the third quadrant. Is cos positive here or negative? It is negative. That means that this will give you the answer negative cos of theta. Now you see that cos remains cos. What changes is only the quadrant, whether it will be negative or positive depending on which quadrant you are discussing. Okay, now this same quadrant here, Remember that we call this 180 minus 180 plus 360 minus. We wrote them here. Now, we can also discuss and say, okay, let's get back to the first quadrant. Now we are dealing with 90 degrees, right? 90 degrees and 270 degrees. So we want to discuss, we want to see what changes. Is there any change? So when you are in the first quadrant here, and then we're discussing, this one becomes our 90 degrees minus, this one becomes 90 degrees plus, this one becomes 270 degrees minus, this one becomes 270 degrees plus. Okay, so what is the trick here? The trick here is simple. When we are talking about cos and sine, right? Cos and sine. Once we deal with, remember that here we dealt with 180, 360, 360. Cos remain cos, sine remain sine. In this case, if you are discussing cos, cos is going to what? To change to sine, and sine is going to change to cos. As an example, if you say what is cos of 90 degrees plus theta, the first question is, which quadrant is 90 degrees plus? 90 degrees plus is the second quadrant. Is cos positive or negative in the second quadrant? We all know that it is negative. So the first thing is to put your negative. Now, cos, because it's a 90 degrees, it's not a 180 or 360, it's a 90 degrees. Cos changes to its co-function, which is sine. So this becomes sine of theta. Okay. So if we are dealing with this quadrant, for example, the fourth quadrant, we know that cos is positive here. If we are discussing sine as an example, so sine of 270 degrees plus theta or something, you say, what is this quadrant? 270 degrees plus is the fourth quadrant. And what do we know about the fourth quadrant? Sine is negative there. So what's going to happen? You put your negative. But sine, because it's a 270, sine is changing to its co-function. Its co-function is what? Cos. So this becomes cos of theta. Okay, I hope you got that. Did you get that? So let me just delete this, and then you can take an example of what we are talking about, okay? Let's take one example quickly, and let me just erase this. And erase it quickly, and then you take an example to, I hope you took some notes so that you can remember what we discussed today. Of course, I'm talking fast because of time. This is we are online, we are on Zoom, so we don't have all the time in this world. I'll be talking very fast, try to catch up, and then if you have any questions, of course, feel free to send your questions. Maybe you were practicing or dealing with a sum and you couldn't get it right by yourself. You can send it to us, and then we'll assist you gladly so. Okay. Let me just erase this quickly. Okay, you're getting there, you're getting there, you're getting there. Okay, are you ready? So let's get an example and see how far we can go. I have an example here. If you have cos squared if you have cos squared 180 minus beta, 180 minus beta, okay, multiply by multiply by, remember a dot means multiply, tan 180 plus beta, tan 180 plus beta, 180 plus beta, all over, that's tan 180 plus beta. Sorry, because of space there. Everything divided by, or let's say this is divided by sine of 90 degrees minus beta. Okay, so this is an example here. Let's try to work it out together. All right. So here's what we learned. We learned that the first thing that we do, we look, we say, what is this thing? What is this quadrant here? Okay, so we are dealing with cos on top. This is cos squared 180 minus beta. So you say 180 minus beta is which quadrant? It is the second quadrant, sorry. In the second quadrant, is cos positive or negative there? We know, because of what we just discussed, that cos is negative there. So the first thing is to write negative cos squared beta. Okay, because this means second quadrant. It is multiplied by tangent 180 plus. 180 plus is the third quadrant, and we know that tangent is positive there, therefore tangent will remain tangent beta. Okay, so this down we have 90 degrees minus beta. 90 degrees minus is the first quadrant, and all these trig ratios, they are positive. That means sine is positive there. But now, guess what? This is 90 degrees. This is not a 180. This is 90 degrees. 90 degrees, we know that sine, it will change to its cofunction. What is its cofunction? It is cos. So this becomes cos beta. Okay. So we have the cos squared here, and the cos squared beta here. This will cancel one on top. So you'll be left with one cos on top, cos beta on top, multiplied by tangent. Remember that tangent is simply sine of beta divided by cos of beta. So this will cancel this. You'll be left with what? Sine of beta. So this is how you answer this type of questions. Okay, and you will get it in the exam. Not exactly this, something of this nature. Okay, so you need to remember very well what you're doing. All right. Any questions so far? Are we following? Okay, as long as you are following, that's awesome. So let's look into something quickly, and then we'll be looking into what I call, just to clear off, I know you learned it in school. Remember that as well, when we're having something like that, we are having what we call negative angles. Okay, negative angles. Okay, so what are negative angles really? Negative angles simply mean that if you were on this, you were at the starting point here, instead of going anti-clockwise, if you move clockwise direction, the first quadrant where you are entering is the fourth quadrant. And in the fourth quadrant, we know that cos is positive. Only cos is positive, of course, with its inverse. Okay, so negative angles are actually angles in the fourth quadrant. So we want to know what is happening in the fourth quadrant. So when we have something like sine of negative A, this is a negative angle. It is telling you that that sine is actually in the fourth quadrant. But you know that in the fourth quadrant, only cos is what is positive. So this would have to become negative sine of A. Why? Because sine is negative in the fourth quadrant. Okay. What about if we had a cos of negative A? Cos of negative A, we all know that cos, the negative angle refers to the fourth quadrant, and therefore cos must be positive there. And so this will become cos of A. Okay, so just clearing that off. Some people, when they see negative angles, for an example, they see something like this. They see something like sine of negative theta negative 360. So they get confused. They don't know what to do. The best thing, what you need to do here is to say, step by step, you say, okay, I will take out the negative sign as a common factor, number one. Number two, you need to change this to write it in the form of 360 and then the theta after. So if you take out the negative as a common factor, we have negative sign, and then your 360 is negative here. That means it's going to be positive here. Okay, And then this was negative here, so this will be positive. So this becomes this. Now you wrote it in standard form. Okay, so what is 360 plus? 360 plus refers to the first quadrant. First quadrant, all the trig ratios are positive. Therefore, this becomes what? Minus sine of theta. So this actually is negative, how you deal with negative angles. Okay. Are we together so far? So that's negative angles for you. Let's look into something again quickly. And then we'll take some questions from here. All right. Let's look into compound angles. I won't write, because of time, I won't write all the formulas here, but I'll just remind you. Okay. So you remember the sine of A plus B, right? And then you have sine of A minus B. You have cos of A plus B. We have cos of A minus B. We have tan of A plus B. All of these, the compound angles, the formulas, they are in your textbooks. Okay, some schools, when you're writing, they will give them to you in your question on your answer sheet. You will have them. Some schools you may not have them. Okay, so just know the trick how to deal with them. As an example, this one here, sine A plus, that is simply sine of A cos of B. If it's a plus for sine, since when it's a plus, it's going to be plus cos of A sine of B. So if it's a sine, the sign here, meaning the plus remains the plus. Okay. If it's a cos, the plus becomes a negative here, the negative becomes a plus here, and then of course, if it's a cos A plus B as an example, this will be cos first of A and then cos of B. And then this becomes negative, and then sine of A, sine of B. Okay. So these are the formulas that you need to learn. Now I want us to look into one last example that I want to deal with you, and then we'll look into the questions. Okay. So let's do this example quickly. Because sometimes you get these questions in your exam and then you seem not, it's as though you don't know what to do. Okay. Look at this thing here. Look at this. If we have sine of 40 degrees, as an example, just on the side, sine of 40, right? That thing, we can write it as sine of 90 degrees minus 50. Why? Because 90 minus 50 is actually 40, so it didn't change anything. Okay, but what do you know? You know that 90 minus is the first quadrant, and in the first quadrant, sine is positive. Okay, so this, but you know that because it's a 90, sine has to change to its co-function. So this will become what? It will become cos of 50 degrees. This is like the theta. We've been talking about theta. So this is like your theta for now. Okay, so this changed to its co-function. Now, what I'm trying to tell you is this. With cos and sine, when you have sine of 70 degrees, you can know that this thing is as good as cos of 20 degrees. I'm sorry, my highlighter, my marker is misbehaving. I was saying that if we have sine of 70 degrees, it's as good as cos of 20 degrees. Why? This is what we are going to do. We are going to say sine 90 minus 70. Sine 90 minus 20. Sine 90 minus 20 is what? Is sine 70. But because it's a 90, it has to change. Sine will change to its co-function. So it will become what? Cos 20. Okay, so if we have cos 60 degrees, cos 60 degrees is the same as sine 30 degrees. They are equal. Why? Because of this thing that we are going to do here. Okay, so let's get to do more serious examples now. This was just a recap from what you learned in in the previous year. All right. Now there's a nice example that I'm giving here. I want you to look at it. They say if cos 25 degrees is equal to t. Look at this. They say if cos 25 degrees is equal to t. Okay, they're giving you this. Imagine question number 3, mathematics paper 2, and then this is the first question. They say if cos 25 is equal to t, they say calculate the following in terms of t. Determine the following in terms of t. Okay, that means they say number A, determine tangent of 25 degrees. Number B, they say determine sine of 25 degrees, sine 25 degrees. Number C, they say determine sine 65 and then sine 245. Sine 65. I won't take all of them. Let me take the last one here quickly. And then we have cos minus 335. D, cos minus 335 degrees. So they are saying that if cos 25 is equal to t, determine tangent 25 degrees, sine 25 degrees, sine 65 degrees, and cos minus 335. Remember, the best way to answer this, these are free marks that you are not supposed to leave. Okay, these are free marks. This question will be about maybe 10 marks or so, so don't leave it. Okay, so what you are going to do to answer this, you are going to draw a triangle, a right angle triangle, so that you can get to know what you are doing here. So you see, this is your right angle triangle, and then they give you cos 25. That means this is like your theta. So if your theta is here, you're gonna put 25 degrees here. So if this is your 25 degrees here, right? What is cos equal to? Remember, cos is equal to adjacent over hypotenuse. So that means that this thing here, you can write it as t over 1, where this is the adjacent side, and this is your hypotenuse. That means t is your adjacent side, this is the adjacent side, and then 1 is our hypotenuse. That means what don't we have? We don't have the vertical side, the opposite side. Then we have to use Pythagoras theorem to determine the opposite side. Okay. Do you remember how to do that? So we have a 25 degree here, and then let's go, Pythagoras theorem. We're going to say this side here, let's call it, y squared, of course. So Pythagoras says r squared is equal to y squared plus x squared. Okay. We have this as 1 because we define this to say it's t over 1. So this is our r square, our r here. So our r is 1 squared, which is equal to our y, that's what we are looking for, y squared plus x is the adjacent side, so it will become t squared. Okay, and then we transpose it. We are looking for y here, we are looking for this y. So if we transpose everything, we take t squared the other side, we're going to have 1 minus t squared is equal to y squared. I hope you can see that. I'm sorry, my marker is just misbehaving, but we can as well be listening to what I'm saying. Okay, so when you want to solve for y, we're going to have y is equal to, you take the square root of this, of course it will be plus minus the square root of 1 minus t squared. So this is your opposite side here. This is your y. Now with this then, remember that if this is 25 degrees here, this is 90 degrees, this automatically becomes 65, because all the sum of triangles in a triangle should give you, the sum of angles in a triangle should give you 180, they are adjacent. Okay, now we're going to answer the first question. It says, what is tan 25? Tan 25, tangent is opposite over adjacent. So tan 25 is opposite over adjacent. That means this is our opposite here. So number 1, tan 25 will be equal to that thing there, 1 minus t squared inside the square root all over t. Tan 25 is equal to opposite. Tan is toward, opposite over adjacent. And our opposite here is this thing that we got in the square root and the t that they give us. And here we have a 1. Okay. They say, what is sine 25 degrees? Sine 25, sine is opposite over adjacent. What is our opposite? We just calculated it here, which is 1 minus t squared inside the square root over 1. So sine 25 will be this over 1. Okay. And then the third one, they say what is sine 65 degrees? Sine 65 degrees, we know sine is opposite. Now, this is our 25-degree angle. This is our 65-degree angle. Now, if we are here, which one is our opposite? T is our opposite. Therefore, this one here will become T, which is opposite, and then all over hypotenuse. Okay, so this will be opposite over hypotenuse. So this is T over 1, which is sine 65 degrees. Okay, the last one is cos negative 335. So what is negative 335? We know that negative means the fourth quadrant, and in the fourth quadrant, cos is positive. So this simply is actually cos 335. Okay, and cos 335, how can we change it? We're gonna write it as cos of 360 degrees, 360 degrees minus 25. And which quadrant is this? 360 degrees minus is the fourth quadrant where cos is still positive. Therefore, this is just cos 25 degrees. And cos 25 degrees is what we got there. It is simply equal to t. That's how you deal with it. Okay, so you saw the trick. What I did, I said, okay, this is 335. I changed it 335. I changed it into 360 minus 25. Because 360 minus 25 is actually 335. Where is the negative? Where did the negative go? Remember that the negative, I said it means the fourth quadrant, and cos it is positive in the fourth quadrant. So the negative, you throw it away because cos is positive. This is a negative angle. The ones I was talking about here. Remember, I spoke about negative angles. So this is a negative angle here. Okay. Yeah, so that's one example that you can also get. If you have any questions, you can send us. I see we have one question from one of our participants. I would like to, let me take the question, and then we will look into more examples here. Okay. Okay, they say it's question 5. Someone was writing mathematics paper 2. Question 5, they gave you a diagram. And okay, let me just delete this and then we can look into it. All right, just a few more minutes. Let me delete this. Then we can look into this question that someone just sent it to us. And we will help the person. Okay. If you need, of course, private lessons, you need private tutor for mathematics. You can also signify, tell us, inbox us, and talk to us, and we will help you at, you know, very affordable prices. Our students, we produce distinctions. We have students who have produced distinctions in their metric. Metric, remember, in South Africa, is the last grade, the last class before the entrance to university. Okay, so if you need private lessons, you can just leave a message there for us and we will attend to you. Mathematics, remember that people, they feel mathematics is difficult, etc. But mathematics is one of the easiest subjects you can ever come. It only needs one thing, two things: understanding and passion, love. You need to create or to have love for maths. Once you have love and you understand it, you understand the formulas, you understand what is happening, you won't go wrong with maths. So fall in love with maths and get to know the formulas. It is very easy. We want students who can produce distinctions, A+ in mathematics. Okay. Not because you copied somebody, but because you understand. Someone says, what is the importance of maths? If I'm going to work, if I'm a policeman, I don't need mathematics. That's a wrong way of looking at it. We need mathematics in our everyday lives. Okay. Imagine that tomorrow you are having a child who wants to be an engineer, comes home with a homework, mathematics homework, and then been hearing that you used to be smart in school, but you can't help your own son with maths. So learn maths now, so that in the next 5 years, 10 years, when you have your own family, imagine that you want to start a company, you understand, that requires maths. or you want to, even when you are buying a car, if you're starting a company, buying a car, buying a house, if you don't understand maths, they will pay high, the type of mortgages you'll be dealing with. If you can calculate for yourself, they will deal with you. They will just rope you and your eyes will be open. So get to learn maths. It's not that you won't use it anyway. Okay. That's just something on the side. But I'm saying that maths is very easy. Maths is very easy. Okay. All right. So let's see the questions again that we had from one of our participants today. Okay. Right, some questions here. So let me take this one. You can send more questions. If you don't get to answer them yet, of course, we will answer them privately. So, all right. So these two questions that I'm seeing here are actually the ones we just discussed something like this today. But let's see. So the person was given sine A minus 360. All right, let's go. It's about 6 marks. So imagine missing 6 marks because you don't like maths. It's not worth it. Even if you don't like it, you need to learn it. So the question says sine of A minus 360 in brackets. Okay. Multiply by cos of A, cos of 90 minus A. So this is multiplied by, okay, let me my board just dry off quickly. Let me just try to dry it off again. A bit water here. Okay. So this is multiplied by cos of 90 degrees plus A, cos of 90 degrees plus A in brackets, everything over cos 90 minus A and then tan negative angle. Cos 90 minus A multiplied by tan negative A in brackets. Okay, so let's try to deal with it quickly. Now remember that this is the reduction formula that we've been dealing with. So this is negative A here, this is tangent here of negative A inside brackets. So what you're simply going to do is to rewrite this to say this is sine because of my marker is misbehaving. You are going to say sine. Okay, you're going to change this to rewrite it in standard form, meaning the 360 should come first. But you see, your 360 has a negative here. So you're going to take out the negative as a common factor, and then you're going to have a negative before the sign. So let me see if it will write. We're going to have negative sine 360 negative A. That's what it's going to become. So it's going to be negative. Let's write. Let's see what we can write. Oh, my marker. Okay, can you do this and finish this like this? Sine of A, sine of, 360 minus A. It's going to be sine of 360 minus A. I can't even see properly now. Sine of 360, negative, we took it out here as a common factor. Then it's sine. 360 becomes positive, then A becomes negative. Multiplied by, here it's cos 90 degrees. 90 degrees plus the second quadrant. Second quadrant, cos is negative there. So you get negative, but because it's 90 degrees, it changes to its co-function. And its co-function is sine. So you're going to get negative sine A. Negative sine A. Can you write it in your book, even though you are not seeing what I'm writing because of my marker here? This is negative sine of 360 minus A, and the negative sine of A. Why is it negative? This is cos here, they gave us cos. 90 plus is the second quadrant, cos is negative in the second quadrant, but 90, because it's 90, cos changes to sine. And then under there we have all over cos 90 minus. 90 minus is the first quadrant, cos is positive, but because it's a 90 minus, it becomes sine. So it becomes sine A. Okay, and then we have negative tan. Tangent negative is the fourth quadrant, negative angle. And tan is negative 10, therefore becomes multiplied by negative tan A. So what do we have? We have negative. Okay, let's fix this one here. So this was 360 minus 8. 360 minus is the fourth quadrant. Fourth quadrant, sine is negative there, and therefore it's gonna be that negative and this negative multiply. Already we had a negative there, so it's gonna be plus sine of A, sine A, multiplied by, here we had what? Negative sine A, and then all over down we have sine A minus multiplied by negative tan A. Okay, remember we have what? Negative sine A multiplied by negative sine A all over sine A multiplied by negative tan A. Okay, so sorry, this one is positive because we multiplied by the negative here. So the sine will cancel the sine down, and then we have negative sine A all over tangent A, negative tangent A. Okay, we are sorry about the marker. I hope you are following us. You could hear, we can hear what you are saying. So what you are left with so far, we are left with sine A on top, negative sine A, divided by negative tan A. And then negative will cancel the negative. So we are left with sine over tangent. So let's multiply them out. So we have sine over sine A over tangent. So when you multiply, you're going to multiply by 1 over the inverse of it. 1 over tangent. Okay. And then what is tangent? Tangent is sine over cos. So because it's an inverse, we are going to have what? We're going to have cos A all over sine A. So the sine will cancel this sine, and then we'll be left with cos A. Because, so your answer will be cos A. Okay. I'm thinking that we should actually continue later so we can fix our marker, and then we will come back to you. Let's take a short break, and then we'll get back and deal with all the questions that you gave us. Thank you. Let's drink some water.